What's going on, everybody? Mr. Barry here for Algebra 1, and going to start off this week with talking about polynomials, and to a certain extent, what we're going to be discussing here, we have some familiarity with when it comes to the different terms that we're going to see in polynomials. So it will look kind of similar to some of the things that we did, whether that be with equations or with when we talked about lines and slope-intercept form and all those things, systems of equations. But we're trying to add on some of those new and different exponents that we saw last week from Ms. Snyder. So we're going to take a look here to start off with just kind of a clarification on when we're talking about adding or subtracting compared to when we're trying to multiply polynomials, some of the basic rules that are involved with that. So I want to start off with some basic terms that we've seen throughout the year, and I'll kind of reference here specifically maybe some constants and some terms that have the variable x. We've had plenty of work with solving those things and simplifying those things. So let me just pick some random numbers. Let me go with 10, 7, 3x, and get a negative in there, negative 5x. So when we're talking about polynomials this particular week, we've got to make sure that we understand pretty significant rules here. So when it comes to adding or subtracting, we need to make sure that we have like terms in order to do that. So when we add or subtract, we have to, there's no doubt about it, have to have like terms. So in order to actually simplify something or make it look different, we would have to add or subtract like terms. So for instance, like terms here, the four options I have over there on the left, we definitely know that 10 plus 7 would be equal to 17. Or if we had to simplify, it would be 17. We know that 10 minus 7, that would be 3. We know that other like terms, the other like terms here are the 3x and the negative 5x. We know that they, when we add them together, and it's going to kind of look weird here, 3x plus negative 5x would be negative 2x. 3 minus 5 would be, or 3 plus a negative 5 would be negative 2. And if I did 3x minus a negative 5x, that one would be kind of slightly more trickier because you have the minus negative there, which would make it a positive. So we'd have, actually, that would read 3x plus 5x. That would give us an 8x. But contrary to that, if we tried to add or subtract not like terms, so for instance, if I did 10 plus 3x, that's not allowed. They're not like terms. Those aren't things that we can add together. So in the process of trying to simplify that, the only way that we could simplify that, well, we can't. So we would just rewrite down the whole thing, and it would probably make it better if we put it in something called descending order. Descending order is where we have our largest exponent with the variable on the left side, and we work our way down here. Since 10 is a constant, the constant is usually the last thing in descending order because technically its exponent is x is equal, or x to the 0 power. So if we wanted to make that look a little bit better, we could do 3x plus 10 and just kind of put that constant off to the right side there and move the terms around. Again, just for argument's sake here, if I did negative 5x minus 7, those terms are not alike. The 7 doesn't have, or the -7 doesn't have a variable x. The -5x obviously does. So we cannot subtract those two things together. The only way that we would be able to rewrite that down would be in the form -5x minus 7, and we already got our constant over there. Now, when it comes to multiplication, the rules for our polynomials here is that we can multiply anything we want. So we don't need like terms like we do for adding or subtracting. Don't need like terms to multiply. We can multiply anything that we want within these examples that we're going to see this week. So when we multiply, we're allowed to multiply any terms we want. So we know, going back to some of the examples that I've used here previously, we know that 10 times 7, we could simplify that and that would be 70. We know that 3x times -5x, and hopefully this is one of those things that you remember from last week in our exponent rules. The coefficients we multiply. So we will do 3 times -5. That would be -15. We would multiply our variables. So we have x times x. If you need to think about that x having a 1 power, that's fine, go for it. And we know that we add exponents when we multiply our variables here. That are the same. So x to the first power times x to the first power would really be x to the second power. So 3x times -5x, maybe you already knew this and you were ahead of me on this, I don't know. Hopefully you were. -15x squared. So we have that information right there, and if it was adding or subtracting, we'd be able to do 10 plus 7 or 10 minus 7. If it was 3x and -5x, we'd be able to add and subtract those also. However, we've got to just realize here that when it comes to our terms, they don't have to be alike in order to multiply them. They do for adding and subtracting, not multiply. So I think something like, let's go with 10 times 3x. We're allowed to multiply that. So 10 times 3x, we would do our coefficients would be 10 times 3, and that would give me 30. When it comes to the variables, there's only that 1x right here. So we just go ahead and multiply it, and it would be 30x. Similar situation, I'll go ahead and just do 7 times -5x. Again, -5 times 7 would be -35. There's only that 1x hanging around. So when we multiply that out, we'd have to have that attached to our -35. We'd have -35x.